I will cut this. Okay, so let's jump right back. We're implementing the RPS string comp just to learn how to deal with character strings and what they really are. So if we just imagine we throw in something like rock and paper, then A is rock and B is paper. But what is it really? It really is a pointer to the first byte. Fortunately, characters are just bytes, right? A pointer to the first character of that string. So basically, if we dereference A, which points to this rock string here, what we get is a character R, right? That's what we get. And if B would be paper, if we dereference B, like so, or so, then we get a P. And this is really it. And the question that you might have is, if we are iterating over these, well, let's just do this, right? Let's do it first and then we ask all the question. Okay, let's see. Do we have to initialize anything? Well, for all I know right now, I want to increment A and B. And actually, I know more because, and I think that's a very interesting lesson now. Whenever you get a pointer in a function, this pointer can be unset. Possibly, it has the potential to be unset. What does it mean if a pointer is unset? Well, in a well-behaved program, an unset pointer is 0, right? And that's really something you have to check for if you want to write good code, because you cannot trust pointers in a way. Everybody can toss in a 0 there, and if you try to work with a 0, try to dereference a 0, you try to access memory slot number 0, and they tell you that will crash your program right away. Therefore, you definitely have to check if these pointers are 0. So if A is 0 or B is 0, bail out right away. I mean, personally, if I want to re-implement string strcomp, I probably would have to read the text just to see how it's supposed to behave if a 0 pointer is passed in. I have no idea how it's supposed to behave. I'm just saying, what should I return? Actually, I don't know. Some error code. Actually, I would like to crash the program. Maybe I just let it crash, but on the other hand, that's what I didn't want to do. So I just return -2. But this is really what I'm doing now, is I'm setting up some sort of weird API. I would really love to kind of tell the user that he's not supposed to put in a 0. But, take my word on this. You have to check your pointers. Otherwise, crashes will be imminent. And you don't want that. Or you want to assert for this. Actually, that might be a better choice, but then putting in some sort of weird, I return -2 if there's a 0 in. I mean, it doesn't make sense, right? So let's put in assertions. That seems a bit nicer to me. Assert.h. That gives us the assert macro. And there's something very interesting to know about this. For instance, if I'm using this now, assert A, assert B, what happens is that in debug mode, this code will be something like, if not A, then throw an exception. No, it doesn't throw an exception. Then cause the program to abort. We're in C here, so in C there are no exceptions. C++ would be a different game, but long story short, if we have a 0 here or here, a deassertion will make sure that our program stops nicely telling us the line number where the issue happened, but only in debug mode. In release mode, because this is a preprocessor directive, I just jumped there, right? So here's my definition. So C define, assert, blah. This means it's a preprocessor directive. So if we are not in debug mode, this will actually do nothing. This will be replaced with nothing. So there's no code. There's basically in release mode, there's no overhead for checking, which also means that in release mode, the program could now crash because it really tries to access a 0 pointer. This also means you have to test your program right. You need test cases even in C, but that's another story. Just be aware of this. That's only good for debug mode. Fortunately, I am in debug mode right now. All right, let's go back to our for loop. I got as far as knowing that obviously I want to increment this pointer, because if I increment this pointer, if I say plus plus, all of a sudden the pointer points to the next character. Points to O, another plus plus, points to C, another plus plus, points to K. Same with the paper, in case we pass it in and in case that's our B pointer. So that makes total sense. If not, go back to the last episode or to someone telling you what pointers are and how they work, because this should make sense to you by now. And as you can see, I didn't bother initializing this because I can just use the pointers that are passed in. I can change them. Well, you could be confused because you said you can't change the value of the pointers, which is true. That's the constant char. That's the value of the pointer. I can't change it, but the pointer itself is not constant. Remember, I think in the previous episode I did that. Oh, actually I did it here. Look at that. Choices are valid. Suddenly I put in a const behind it. A const can refer to the thing on the right or to this thing on the left, depending on the context. So this const refers to the pointer here, which says, oh, you can't change the pointer. I can't change the value of the pointer. Last time I kind of showed you by doing the plus plus C, which was causing this. Just a reminder, that's just a little bit of repetition. But in this case, there is no const pointer, so I can change them. That will be fine. By the way, it's always a good thing to return something here. I don't know if it's valid to not return anything, even though you declared it like so. The compiler should at least warn, but let's have a look at that. At some other point. Right now I just put in something. Right now we don't have a real loop because, well, we do have a loop, which is an endless loop, which will, well, right now it would just cause the program to never finish. So we should know when to abort the loop, right? And that's the interesting point. This is really another and one of the major features of character strings, and this is something, that's the only other thing you have to remember. Even though we don't see it, I mean, well, let's put it differently. What do you think? How many bytes does this rock string have? I give you a hint. 1, 2, 3, 4. But that's not the case. It's 5. And I don't even want to select this because this could make you think, oh, there's this quotation mark in there, which is just not the case. But there is kind of an implicit last character value in each string, in each C string, which is a 0. So there is in this case, a 5th character that we don't see anywhere, but it's there, that has the value of 0. 0 is a special value. No encoding in this world, like ASCII, will use or will assign some sort of Latin character to the value 0. 0 is always special because 0 is the value used to determine when your string is over. So this is how C strings work, right? A C string doesn't actually tell you anywhere how long it is. If you want to know how long it is, you have to go through all the characters and read them until you find one which is 0. This is how this works. And this is really the only thing that we have to know here in order to compare our strings and to find a good abort condition. So not A or not B. Does that make sense? Oh wait, actually I kind of turn around the logic, so that did make sense. A and B, oops, like that. So that makes more sense. Because now I say that I only want to continue if both values are set. Okay, so that would do something. And yeah, I don't really know how I want to do this, but at least I know that my loop will abort if one of these character pointers points to 0, so if we reach the end there. And okay, so now once we're here, we can just compare the values, and if they're unequal, we know that the strings are unequal. That's something we already know, no matter what. If A doesn't equal B, then we return, yeah. So I don't know the implementation. I just return -1 to say it's not equal. And that's not really string comp. I should really check the text, but on the other hand, I don't care too much because we just need, you know, a 0 here to indicate what we want to indicate. All right, that's probably an ugly string comp too, so I apologize. If you find better string comps anywhere, you will. Then yeah, that's how it is sometimes. Good, but now, once we are past this loop, we could have two conditions, right? At least one of the strings is now at its end. And if both of the strings are at their end, this means they have the same size. And it also means that they have been equal so far, which basically means that we can return 0, right? And otherwise, if one string is longer than the other, then we know that they are definitely not equal, even though they have been equal until we ran out of characters in one of the strings. Okay. So I can now check if A is 0, or if we want to do it concise and C-ish, if A is 0 and B is 0. Actually, I don't like it. Just not A. I mean, you can do it, but let's be more specific. If A is 0 and B is 0, then we know that both at the end, and apparently they have been equal so far, which also means they are equal, which means in consequence that one of them here, if you reach this point, you know, one of them must be longer, so we can't assume they are equal anymore. And that should be a string comp that works. I'm just compiling this, which seems to have worked. Now I'm running it, and it says we tied, which probably means that we've been doing well. That actually works. Yeah, that does work. There's nothing more to say about that. But let's not trust it, right? Let's just test it a bit more. I make this a bit larger for you. And now let's take rock and rocks. I should tell it's invalid. So, and that's already, you know, if it says it's invalid, then we know that the comparison failed there, because it tried to compare rocks with rock, paper, scissors and had no match ever. So it realized that we are wrong. Awesome. So this is that. 20 minutes later, and we have already learned everything there is to learn about strings and or character strings and what they are. There are different versions of this. Basically, there are also wide characters. Wide characters don't use bytes, but they use 2 bytes per character, and thus can support different encodings, character encodings, so more than ASCII. And you know. But we can't, I mean, this is nothing we have to be concerned with, because rock, paper, scissors just uses the ASCII encoding here, and that shall be fine for us. But let's just keep it like this. Encoding is important, and you always, I mean, depending on what you are doing, you always should be aware of the encoding that is in your strings. Because, I mean, there's lots of stuff to learn about that. I don't want to talk about Unicode right now. But if you have no idea about character encodings and Unicode, you should probably have a look. Just so that you don't write software that will not work in China or that will not work in Japan. And it's quite easy to write software like that. You wouldn't believe it. But I think C should be second there. You should first understand that kind of stuff in Python. And once you've tackled that, you can move to C, because C will be a bit more complicated when it comes to handling of encodings and handling of Unicode. That said, when I remember the old days, the good old days, when the entire program here would fit onto one screen, I think that's something I can delete by now. Then I must say I liked it. It seemed so simple. And now the program has grown to, 65 lines. And it's getting more complex. We have more functions. And if you wanted to, learn about more advanced features, other features of C, like structures and, some pseudo object-oriented programming, something like that. If you want to go there, then I think we would better structure our program, because right now we just have main.c, and there are limits to how far it can grow without becoming unmaintainable or hard to read. So I think I want to split this program up. Let me see how I do this in this program here, Qt Creator. So it shows me that in source C there is my main.c, which is fine. Main.c to me should only contain the command line interface. So that's the guy who parses the arguments and then passes on information to some sort of game engine. Oh yeah, it's a big word, a game engine, for something like rock, paper, scissors. But what I'm saying is we should keep our concerns separate. We should have one part of the program that only deals with the game itself, and the other part of the program deals with the user interface. And the user interface in our case is just a command line, right? But it's still a user interface if you think about it. And these parts should be separated. This makes everything easier. It makes your code cleaner, and it makes testing possible, or let's say testing easier. In this case, I would even say it's probably overkill, because this is totally fine. If I want to test this program, I would just if I want to test this program, I would just write a shell script that calls the program itself with some arguments. That should be totally fine in this case. But we want to learn something new, so I guess splitting it up is the way we go. There's a question by Motoso in Twitch about for unsigned long. Is it okay to declare variables within the for statement? Shouldn't they be declared beforehand? I think that's something, I forgot his name. Someone brought it up in Gitter as well, that this stuff didn't even compile unless you specify C99. Where is this? For unsigned long, here it is. Unless you compile it with C99. And I think C99 is something that is reasonable to assume to be available on all the platforms you are going for. It's even available on microcontrollers, I suppose, like small CPUs, real small hardware. And besides that, and that's really why I'm doing it. I wouldn't care, but the reason why I really want this feature, so I say C99 is what you want to use, or C++. If you define, I define this symbol here and initialize it. If you define it here, it will only be valid within this block, within this scope, within the scope of this for loop, or within the scope of, that's pretty much it, within the scope of the for loop. This is what you want, because then there's no chance that somehow you reuse the CID and maybe use some non-zero value on it. I tell you, if you do this, then this is a source for, oh no, wait. Actually, you can, I think if it's kind of C style, you would do it like that. Here you can still initialize, but you have to declare it somewhere else. If you do it like that, that variable does exist here as well, which can be what you want, but most of the time it's not what you want. And it's a source for bugs to, well, not use a reasonably recent C implementation. That's just what I think. So I recommend doing this always. All right, back to our compile units. Oh, compile units, that's a term. That's a term I might have used for the first time, kind of. Main.c, every C file, or every file that is handled by the compiler is a compile unit. Because every compile unit produces an object file that basically contains, I don't really know what it contains, kind of the compiled assembly stuff that will make up your program later. And all compile units later are taken and put into, oh, there's a storm outside here. Don't blow away my home, please. So every compile unit is later taken and linked into the final program. And right now we just have one compile unit, which makes it really easy for us to, well, keep track of our compile units, but it also imposes certain limits to the complexity of our program. So let's fix this. Okay, I would, excuse me, I would like to have some sort of game engine, right? I would like to call it RPS. And let's just start small right now. Add new. Oh, well, that's awesome. C++, class, no thank you. Let's just go with a text file then, and rename it. Desktop templates. Maybe it's different. I just want a C file, but anyway, I think text file should be okay. So nobody writes C with Qt Creator, that's what I think. Oh, there I can name it, awesome. So I call it rps.c. Should be there, thanks. Add to version control, sure. Add to project, I think so. I want to compile you. Sounds good. Sounds good to me. Good. And the thing about compile units is that they're totally separate, right? Unless you kind of bring in symbols that are in other compile units by importing declarations of these symbols. Right now what we have here is definitions of symbols. It's all definitions here. Definitions are basically, if you write the code for the particular function right here, that's a definition. And that's totally all right in that compile unit, right? It's fine, you can do this. But we can't use these definitions anywhere else. So if I want to basically put all the code that is related to my RPS game into a separate compile unit, then I have to find a way for this main compile unit to use these definitions. And this is done through header files, where I declare the functions that are defined in some compile unit. And that's really it. I can define these in any compile unit that I like. I can split this up. I can have one header and 5 compile units that implement different aspects of that single header. I can totally do that. What's really important is the header that makes all the right declarations. And that's something we want to try now. Let's see how that works. So rps.c, that's where the definitions are going to be. But I will need a header. Text file, sure. Call it rps.h. Add it to the project. There we go. There is a header now. Awesome. And it's totally empty. All right. There was just some chat message coming in and there was no question. Good. So yeah, I just brute force it now. I don't think much about what I'm doing now. Assert I need stdio is something I need in main. So I'm just going to grab this code, input ID choices are valid, and put it here into my header. Sorry, I didn't mean that. I meant put it into my rps.ccompile unit. That looks much better. Okay. And let's check the interface that we have to expose. So what does main really want? What does main really use? Okay, I'm now switching back to full screen here because I can switch between files more easily. So we have rps.c, rps.h, and main. Let's have a look at main. P choices. So now, as you can see, input ID is unknown because nobody declared this function. You know, the code is somewhere else now. Input ID at once. Then choices are valid at once. And then it actually applies some game logic here that we, you know, the main is just a UI, it shouldn't apply game logic. So this line has to move somewhere else as well. But let's start step by step. I'm thinking how my interface should be. How do I want to do this? And what I'm thinking as far as the RPS game is concerned, it always wants to have two strings, player 1 string, player 2 string. And from there, it will actually tell you what's going on, I think. Yeah. And we can just define how we decide on how we wanna do this. If you think about it, as far as the game is concerned, it should be able to tell you which player is or has made a wrong choice, an invalid choice, and it should be able to. Oh, we just have 15 minutes left, so maybe I have to hurry up here. And we shouldn't kind of confuse the UI in the sense that the game engine itself is not supposed to tell you this kind of stuff, I think. Because it's, you know, if there's a if there's some front end, some cute front end, then you don't want to print stuff to standard output. Nobody's going to see that anyway. So the one who uses the game engine needs to figure that out himself and then do the right thing with the user interface. So basically a lot of this code has to move somewhere else. That's how I see it. Basically in the game engine, which is in rps.c. How would we want to call this? I'm just thinking, you know, I'm trying to figure out an API here that could make sense. So I would like to do something like RPS match maybe, because we want to run an RPS match. Does it make sense? Maybe it does. Maybe we find better names later. And then I want to pass my arguments, which is player 1 and player 2 choice. And now I can have the following return values. Player 1 is invalid, player 2 is invalid. We have a tie. Player 1 wins, player 2 wins. That's kind of the possible results that we can have. And that's in a way, that's a switch case maybe. Let's try that. And now I would have the individual cases and I can do what I want. So this also means that this result computation, it totally goes somewhere else. It totally goes to RPS match. And here we do all the printing that there is. And all this stuff goes away. From main at least, it goes somewhere else. It goes to RPS match. This also means that the only function we ever want to call, that we ever need in our header, is RPS match. So first, let's include our own header here. Let's keep a little space, rps.h. See what I do? I use these quotation marks. just to indicate that I want to search my custom search path, like my project search path first for the matching include. Let's see if that even works. We will find out, but it should. I think it should. The reason why I don't know is that I'm relying so much on Qt Creator to do the right thing under the hood that I have no real idea how it's actually doing that, right? You should always know your build system. Right now I don't. I will just find out if that works or not. Okay. So then I will maybe return to the switch case. By the way, this is kind of wrong. I think it's made like this. And then I would like to do something like RPS invalid P1. And then I do what I have to do. And now we learned something about the switch case in C, which is tricky in itself, because whenever you get into such a case here, I mean, let's just say, I mean, we'll learn about this RPS invalid. It's some sort of constant that I'm using here, right? It's a constant that I didn't declare yet. I also didn't define it. It's not yet there. But what you have to do is, if you hit this case, you always have to break out of the case or make sure that this thing returns, and otherwise you will fall through to the next case. RPS invalid P2. And I just do my breaks here because that's something you should never forget. And then what else do we have? Then you have the tie. Okay, is RPS tied. Yeah, I mean, it wants to put it here all the time, so let's put it there. Okay, is RPS P1. Let's do it like this. Naming conventions. Maybe it's better like that. Seems more natural to me, at least. RPS P1 wins. And last but not least, RPS P2 wins. And now, don't forget the break. That's a huge source of bugs. It's getting laggy, yet the audio is perfect. I don't know why. Maybe the storm outside is killing my internet connection. I have no idea. Sorry, I can't fix this. Maybe I have to upgrade my internet because my upstream is really bad. Just 1 Mbit, and it's barely enough to do this kind of stuff. That's for sure. Live streaming is not for me right now. YouTube recording is better. 7 minutes left. We might not finish this today because I'm just too slow with that, but I will try. Okay, so we said that all this stuff goes away. RPS match. Basically, all we need in main is information about the values of these constants, or maybe it's an enumeration even. And we need RPS match, and that's all we need. And the rest we can then figure out here, because even this thing here goes somewhere else. All right, I just move this code around now. RPS.c. So these are all internal here. I will keep them, these functions, and add RPS match, which is returning this enumeration like this. And I really have to check myself now how enumerations work again. C99 enumeration. Yeah, how to do that? Stack Overflow to the rescue. Yeah. That seems like what I want. So that way I can just define a new type that can take one of X enumeration values, the ones that I define here. They can also be initialized with a value. They usually it usually comes down to those being integers, which allows certain cool things to happen. But as far as we are concerned, we don't need to assign values here. We just need the enumeration itself. All right, let's do this. Typedef enum strategy. So now I have to think about it myself, because I have to define it somewhere, and it just needs to define. I mean, that's important, you know. Each symbol needs to define exactly once. If you define your symbol, or a symbol with the same name, in multiple compile units and then try to link that, then the linker will say that this obviously doesn't work. So we have to be careful about this. So for now we keep our definitions here and figure other things out later. All right. RPS P1 invalid, P2, P1, okay. Memory, brain, do your thing, try to remember. P2 invalid. Let's do it like this maybe. Then we have RPS P1 wins, RPS P2 wins, and RPS we tied? What was it? Brain? Main? I have to look it up. RPS tied. Let's call it RPS tie. Okay, that seems better. RPS tie. And we call this RPS result. And again, I don't have a particular coding style here or coding conventions. I just do it as I see fit. If you have a real project, you probably want to figure out what you want to do there. So let's go back to our RPS match function. We now return RPS result. RPS match. We take player 1 pick, and we take player 2 pick. And that is that. And now we can put all of our code here. And see what we do with it. So first, choices. Here we iterate over it, but right now we can actually just hard code that. Let's keep it very simple. That's not the most efficient code ever. I mean, it is kind of efficient because I don't even loop through things, but yeah, I think it shall be fine to just hard code it, even though I personally don't like that so much. But in this case, well, doesn't matter. So what we do here is pass in our player 1 pick, P1 pick. Oh yeah, and here we can just hard code it to 0, hard code that to 1, player 2 pick, and then we basically have the choices here. I mean, we check for validity. And yeah, we don't print anything. That's part of the UI now. We just want to figure out what the result is and then return the right thing. So we can only handle 2 players. So let's do this. Let's do a switch case again. Switch cases, do you like them? Do you not like them? Are they cool or not? So if it's 0, yeah, I don't know. I don't like them because of the break, but in case you can just get out of here, like I can, I think a switch case is cool. So case 0, I return RPS P1 invalid. Case 1, RPS P2 invalid. Nice. And the default case, the catch-all, and I'm putting in a default just to protect myself from errors, right? Because it could be possible that at some point we support 3 players, which makes no sense, but maybe, and we just want to be sure that, you know, we don't just do weird things. So I'm putting an assertion here. I don't know. Assertion that always fails. And because this will only be there in debug mode. Oops. What? Something is... Actually, it's right. Because that only goes in there in debug mode, I will also, in that case, you know, I want the program to crash, in fact, but maybe I just return RPS P1 invalid. But in debug mode, at least, we would have this crash at the right spot. All right, and now we have to do our player choice. It's again this mapping. So the results, that's something that wants to go to main now, because we don't really care about that anymore. Well, does it even want to go to main? I don't know. For all I know, we don't want it here. So just kick it out. And then I guess it's a switch case again. It's kind of, you know, if we wanted to, we could do this more in a more fancy way. We could basically assign decent values like 0, 1, and 2 to these numbers here, and then to these enumeration values. And then we can just take this integer and cast the integer to the enumeration value. And we know it's the right thing. It's something we know, right? It's something we kind of enforce. So this can always break if you don't know about that anymore. So it's probably better and safer to just do a switch case here once again. And there are lots of brackets here, and they don't match up. Come on, maybe one too much here. Do you make me count brackets now? So one is missing there, and maybe like, oh, come on. Where is this going? So that's not closed. So what's the problem here? Why does it say it's wrong? Tell me. Expected that token, got that. Oh, damn it. Silly me, there's no array access anymore. All right, that is it. So, case 0, we tied. Return RPS tie. And I know we are using too much time, and I will do it as usual. I think we will finish this in about 5 minutes, so let's speed it up a little. RPS P1 wins, I think. Case 2, RPS P2 wins. And what we did is we put all the game logic into this one function that kind of figures out what happens there just by using the arguments, and that's what we want. There's no UI involved, no printing of whatever kind, and that's what we want. And the picks are just character pointers, which is fair enough for our case. It's kind of, you know, it's not really what programs usually want, because, you know, picks can only be 1 or 3. Probably you want to pass in some enumeration here, but I think that's still simple enough and kind of is doable as an API. It's okay. Let's not forget, you know, programming style. Let's keep it real and stuff. Let's put a default case here, and I will do the same thing. I will assert false, because we should never get there. You know, if we get there, then the rules changed or something, or this array got larger. And we really shouldn't have this happen. Unfortunately, there's no better way to test this. So really, we need test cases for this to be sure that we don't break the game if you wanna put in a shotgun here. You know, we have to be careful now because things rely on the numbers basically. And last but not least, we return, well, what do we return? Some sort of invalid thing. I mean, it would be good if we have some sort of generic error code, something like RPS error, you know, RPS, something like that. A generic error that should never happen. And of course, if you're good, you would kind of declare what that means or comment what that means. Right now I don't, because I'm not good and I have no time. So let's do it like this. That's what I like much more. RPS error is now a valid return. RPS error, and there we go. So that's our game. And now we just need to declare it so that, or make the respective declarations so that main can use it. So let's go to rps.h, and I keep the header really simple. This is a very minimal header that is still missing one part, but as far as we are concerned, we shall be fine. So that's the declaration. As you can see, you just don't define it, you just leave out the curly brackets here, and all of a sudden it's a declaration that makes total sense. RPS result is an enumeration. And let's see how we declare that. Enum typedef RPS result. All right, let's see if that works. I have no idea if that can be linked, to be honest. I have no idea. We will see. Because I need to declare this type. I don't really want to define it here in my header, because definitions in headers are pulled in everywhere. That easily makes duplicate definitions that will prevent your program from linking. So you really just want to declare that enumeration here. And I would like to tell it that it's kind of extern, that it's coming in somewhere else. And yeah, I will figure that out. Extern is usually a keyword that says that it's coming from another compile unit. And yeah, I actually don't know. Let's find out. Let's see what the compiler says. So now we have RPS match defined here. We have RPS declared. We have RPS result declared. Is there something else we need? No. So my question is, can it not find the header, or what? It can find the header, because for some reason it didn't light up my RPS match function here, even though it can find it. Okay, so maybe the editor is confused. That is, oh wait, there was something like, I think update translation. There is some sort of function, tools maybe, tools C++, inspect code model, update. I thought they had something like force update of symbols, but apparently they don't. Running out of time as well. I think the best thing now is to just see if this compiles. Something tells me that it does not compile, especially because of this. It's not argc, it's args. And can it follow this? No, it can't follow symbol. So something tells me that this is not really there. Yeah, I think that will not work, but let's build it. Oh yeah. So how do I declare an enumeration? C99 declare enum. Yeah, how to define, that's awesome. That's CPP. Can I just put it into the header and it will be fine? Yeah, you know what? I will just do it. Even though I'm a bit unhappy about this, But we will see how this evolves. We'll just do it like that. So let's take this and put it into the header. Usually you don't define things in a header, right? Right now I'm doing this. Okay, user one declared identifier RPS2 win. True. Look how smart he is. Did you mean RPS P2 wins? I did mean that. Awesome. See, and now these turn into a nice color, which basically means that still didn't change color. So what? RPS P2 wins. It's there. It's definitely there. And why does it tell me it's not? Oh, I put a 2 there instead of an S. All right, call me stupid. There we go. Let's build that. Oh my God, use of undeclared identifier result. Ha! True, we killed this, right? That's not in existence anymore. We have to redo this. And then there's some other stuff. Unknown type, RPS result. Oh look, why is that type unknown now? Because I didn't include my header. We need the declaration of this enumeration. Besides that, we should be good. Okay, let's try again. Use of undeclared identifier, false. Ha! Fine, I don't want to include bool here just because this guy doesn't know it. Let's just make it like that. Num results. Haha. Yeah, we just use it twice. I guess we can just have a static constant integer called num results. That is 3. Oh wait, actually it's related to this, right? So we could do the size of game. Could do the size of game here. Num choices, we call it. And then it's size of choices divided by the size of one member of choices. And there we go, num choices it is. Put it in here. Thanks. Now we don't have to hard code that here. We are better that way. And now I would assume this compiles. It builds. Yes, it builds. And unfortunately, we have no output anymore. We just have the most primitive output there is, and now we have to basically have an output line here. So do this real quick. P1 invalid. You know, we can have awesome text here later. I just print it here. And yeah, not to forget, return 1. Let's just indicate which player is invalid. Return 2 for player 2. Tie. I mean, from now on, you know, I think I just want to fall through and return 0 because now we have real game results. And all I want to do is basically print this with a printf because I don't care. Well, std out is fine, right? Tie. And something I forgot, obviously, is this. 1 minute to go, then we have taken 15 extra minutes. I'm really, every time I'm overshooting, I'm sorry for this. I'm sorry. I think if I would be real good, I would be able to manage my time much better, but I can't. P1 wins. And copy paste, quick. P2 wins. And I would expect, damn it, I copy pasted errors there. Oh look, silly me. And return statement is missing something. All right, that should print something. Yeah. And there was an error compile issue. No. Let's recompile that. Ah, look at that. That's good. It tells the truth. It absolutely tells the truth, because I am missing my error handling here. And you should really handle all the cases that there are. It's really, really good. So that's the last case we have to add, and then we are done. Case RPS error. And yeah, fprintf as usual, std error. Some weird error. I will return something else here, like 255, unexpected error occurred. Bad, evil, really bad, shouldn't ever happen. And now the compiler says it's all right. And I say, for now we are all right as well. So that works. Thanks for watching. In the next episode, we will clean this up a bit. And maybe try to use structures. We try to do some sort of object-oriented game engine design and maybe make this even fancier. You could doubt that this will be getting better here from now on. It will only get more bloated, more convoluted, because the simple solution we had in the first implementation, and now it only gets more difficult. On the other hand, it's such a simple game that it's probably not a bad idea to use it as an example for all the C features that you probably want to use in more complicated programs at some point. All right, that's it from me. Have a good night, and I hope to see you next time.